Okay. So where we are on last lecture on this slide, this one. Okay. So we can see here. सगळ्यांना आवाज येतोय का रे? Hello.
Yes, sir.
Okay. Only सीमा मालटेच आहे का? बाकी कोणी नाही आहे का? Okay. So this is the electromagnetic radiation. Let me see here. If you think about the light, specifically visible region, you can see because of their radiation range, because of their wavelength, it's suitable for our eyes. Okay. But if wavelength goes on to be decreases, means if you see the ultraviolet light, it is a higher energetic light, is cosmic ray, gamma ray, X-ray. So these are the higher energetic radiation. Okay, that we can see here. If you consider the gamma ray, so we can see here their wave is very closer. Wavelength is very closer. Let me see here. So we can say there is a small wavelength. Okay, there is a small wavelength, and if you wavelength is small, so wavelength is inversely proportional to energy. Wavelength is small means their energy is high. Okay, so gamma ray having a higher energy and small wavelength. Okay, so if you move from this gamma ray to this radio wave, so we can see here the wavelength goes on to be increases. Wavelength, this is the wavelength distance between to crust and trough. So this wavelength goes on to be increases. So this distance we can consider as a wavelength. Means if you point out here, this distance means if this wave start from this point, okay, if this wave start from this point, so it propagated in this direction. Okay, so this distance, this is the crust and this is the trough. So this distance, okay, from this point to this one, so this distance is known as to be the wavelength. Okay, and we can see here at this end of this electromagnetic radiation, there is this wavelength is larger wavelength. Okay, the distance is larger. But if you see here, in case of the gamma ray, if the wave start from this point, okay, let us see, this point is the starting point of the wave and it's propagated in this direction. So this distance, this is the crust and this is the trough. So the distance is very short. Okay, very small distance is there. And their wavelength is very small wavelength. Okay, so this wavelength is small and here wavelength is more.
Promotion सांगा किती तारखेला
17
17
11
11
19
19
So here wavelength is smaller. Okay, and we know the relation between to the wavelength and energy. So energy E is equal to inversely proportional to the wavelength. Okay, so we can understand why the gamma ray having a more energy, why the X-ray having more energy, why the ultralight having more energy. Okay, so the reason is there, their wavelength is small. Wavelength is small means it is a small value of the wavelength, so energy is high. Yes, any doubt? Okay, so their energy is high for the gamma ray, X-ray and ultraviolet. But when we reach to this visible region, so their wavelength is it vary from 400 to 800 nanometer. Okay, let me see here. This is 400 to 700 and 800, means nearer to the 800, like here. This is to the 800 nanometer. Okay, so this region, this wavelength, we can be absorbed by our eyes and we can identify, visualize the various objects. Okay, but this higher energetic light we cannot be visualized. Okay, because this higher energetic light damage to our eyes, because our eyes cannot bear this wavelength of light or energy of light. Okay, but the next, if you move from this to visible region to right hand side direction, we can see here there's infrared, then microwave, radio wave. So these all radiations, they're having a larger wavelength. Wavelength is larger, so that's why their energy is smaller. And this lower energy wavelength, it cannot damage to our eyes. Okay, that's why we are used for this various use in various instrument. Okay, like the TV, FM. For that we use radio. Okay, so this radiation can be used for that. It is not so hazardous for you because of lower energy. Okay, so we are going to be learn about the photochemistry. So the slide is mostly we are talking about the photochemical reactions is there. When there the reaction is occurring in the presence of light. So specifically this light is used from this region. Okay, UV and visible region. So we are talking about, we are discussing about in the chapter about the use of ultraviolet light and visible light as a source for the reaction, okay, for the chemical reaction. And we study about it in the under the title as a photochemical reaction or photochemistry. Okay. So when we talk about the photochemistry, so we cannot be forget the name of Giacomo Luigi Simasian. Okay, it is an Italian chemist, okay, Italian scientist. He was proposed this term is a photochemistry. Okay, he first upon carried out the experiment in the presence of the light, and that's why he is considered as a father of photochemistry. Okay, so what he was proposed, he proposed the photochemistry. Photo means there is a light, and chemistry means the chemical reactions. Okay, there is basically we are discuss about the reaction is occur in the presence of UV light and visible light. Okay, it's from 200 to 800 nanometers reactions. We are going to learn about it. Then photochemical reaction is faster as 10 to the power minus 9 second than the thermal reaction. Okay, as we know that there are two type of reaction is there. One is a photochemical reaction, one is a thermal reaction. Photochemical reaction means what? There is the presence of light for the reactions. Presence of light for the reaction is what happens when the light is interact with the reacting molecule. The molecule get excited and it undergoes to the further reaction. Okay, but in a thermal reaction is there, in a dark reaction is there, there is no presence of light. Okay, so in the absence of light, there are some temperature, some catalyst, some solvent, they work for to carry out the reactions. Okay, so these all are considered as a thermal reaction, but this photochemical reactions are faster as 10 to the power 9 seconds than thermal reaction. Okay. Sometimes this reaction often observed as fast as 10 to the power 15 minus 15. Okay, sometimes it observe it more faster at this range. And we are talking about this 200 to 400 and 400 to 800 nanometer reactions. Okay, in this chapter. So the first one is a type of reactions. Okay, there are two type of reaction. One is a thermal and dark reaction. Second one is a photochemical reaction. So we are going to learn about these two reactions by differentiating them. Okay, in one table we are going to understand these two. Okay, so we know that for the any reaction, okay, reaction, when reaction is goes on, so for the reaction some driving force is required. Okay, without driving force, no any reaction go in forward directions. Yes, sir. हो, हा ना, लांबवा ना ते. हो, याच्यानुसारच दाखवून घ्या 24. येतोय का रे बेटा? आवाज येतोय का? आय एम ऑडिबल?
हो सर, आता येत आहे.
ओके ओके बेटा, समजत आहे ना रे? समजत आहे का what I am talking? Are you understand it? Refresh. So समजत आहे ना सगळ्यांना? ठीक आहे. So let me move. So thermal reaction is basically, we know that the reaction means what? There is a interaction of two reactants. Okay, maybe there one reactant, one reagent, one catalyst. Okay, but their interaction is most important. Activation is most important. Okay, so reaction is both in forward direction due to the some driving force. है ना, काही driving force असेल तर reaction forward direction ला जाते. So we use some catalyst, we use some solvent, we use some energy. It may be in the form of heat, it may be in the form of the light. So that all factor, it help to make more activate to the reactant molecule, and then this molecule undergoes to the reaction. And if the molecule is stable, so it does not undergo to the reaction. Okay, we know that every stable person, every stable object, it cannot be undergoes to the reactions. Okay, but when there is a instability in the molecule, is instability in the molecule is because of the more energy. So more energy of the molecule is made by the use of the different object, different terms like this: catalyst, solvent, and energy. So if you provide this uh, factor to the reactant molecule, then it undergoes to the reaction. Okay, we know that हमें पता है कि अगर कोई रिएक्शन होती है तो मॉलिक्यूल को एक्टिवेट होना जरूरी है, so the interaction होना जरूरी है, and for the interaction we have to make it more activate, है ना. इन interaction होने के लिए हम we have to be make it more activate. Okay, then it undergoes to be interaction to each other. So if the presence of light is there, so this interaction is occur in the presence of light, the activation is occur due to the presence of light, so it is called as a photochemical reaction. And if there is no light, in the absence of light, but there are some other factors work for to activation of the molecule, like a solvent, catalyst, in this way. So this is called as to be the thermal reaction. There is the heat energy can be used, and there is absence of light, so it's called as to be the dark reaction or thermal reaction. Okay, let me going to be differentiate these two reactions. Okay, first one, when we talk about the thermal reaction, so collision between molecules of reactant. What happened? The reaction is occur. Reaction केव्हा होते? जेव्हा मॉलिक्यूलचं कोलिजन होतं तेव्हा. कोलिजन म्हणजे काय होतं? इंटरॅक्शन. एकमेकांवरती जेव्हा मॉलिक्यूल आढळतील. When the A and B react to each other. React to each other means what? These two interact to each other. These two collide to each other, collision to each other. Okay, so due to that interaction, what happens? Some electron gain and loss is occur, some bond is break down, and some bond is formed. Then this reaction convert into, then the reactant convert into the product and it gives reaction. So this is called as to be the thermal reaction. It's the first point for this. Okay, but what happen in case of the photochemical reaction? In photochemical reaction, there is the absorption of light from UV or visible region is occur. ओके, काय होतं? एखाद्या बीकर मध्ये आपण जर काही मॉलिक्यूल घेतले, ए आणि बी मॉलिक्यूल घेतले, पण यांचं इंटरॅक्शन जर करायचं असेल तर आपल्याला कोलिजन करावं लागेल, एकमेकांवरती मिक्स करावं लागेल. त्यासाठी आपण काय करतो? काही सॉल्व्हंट वापरतो किंवा त्याला टेम्परेचर देऊन त्याची एनर्जी वाढवतो, ते इंटरॅक्ट होतात, किंवा आपण त्याला स्टर करतो, है ना, किंवा एखादा कॅटलिस्ट वापरतो. So because of this factor, what happens? This reactant molecule get activated, आणि activated झाल्यामुळे काय होतं? मग तो फास्टली मूव्ह होणार, and due to the fast movement, it collide to each other, है ना. फास्ट मुवमेंट झाल्यामुळे काय होतं? त्यांचं कोलिजन होतं, आणि कोलिजन झालं म्हणजे काय होतं? काही इलेक्ट्रॉनची देवाणघेवाण होते आणि काही काय होतं तिथं? त्यामध्ये रिएक्शन्स होते, बॉन्ड मेकिंग ब्रेकिंग होतात आणि नवीन प्रोडक्ट मिळतो. So we can say about the thermal, there is a collision is occurred due to thermal or catalyst solvent. And in case of photochemical reaction, some light is absorbed. Okay, light absorb केला जातो, आणि light absorb केल्यानंतर काय होतं? Energy is increases, है ना. Means if you consider the molecule, benzophenone घ्या किंवा एखादा कुठलाही मॉलिक्यूल घ्या, युरेनियम ऑक्साइड घ्या, किंवा कुठलाही मॉलिक्यूल आपण जेव्हा कन्सिडर करतो तेव्हा मॉलिक्यूलला ऍक्टिव्हेशन साठी एनर्जी ही इन द फॉर्म ऑफ लाईट ऍब्सॉर्ब केली जाते. ओके, मग it absorb the light energy and get activated and then it undergoes to the reactions. Okay, for example we can consider very famous example, very simple example is there is the Cl. This is the neutral molecule. Cl2 molecule is a neutral molecule. Okay, but when it absorbs some energy, okay, हा energy absorb करतो. Energy absorb केल्यावर काय होणार? This bond is break down by homolytic tie. Okay, there is a homolytic bond fusion is there. So one electron from this bond, it goes on this chlorine, and one of the electron from this, it goes to this chlorine. Okay, and we get twice Cl radical. Okay, we are getting twice Cl radical. So what happened? This molecule, Cl2 molecule is the neutral molecule, is a somewhat stable condition of this molecule. But when it absorbs the energy, this molecule get excited. Okay, and due to excitation of energy, it become to be unstable. This bond become to be unstable, and due to that, this bond is break down by homolytically, and it produce two chlorine radical. So this is called as to be the absorption of light. Then free energy of the molecule is decreases. Okay, means what happened? We know that the energy profile diagram, and in energy profile diagram, we can see the energy diagram is here. There is a reactant. It's a reactant asto, and then it undergoes to be the reaction, and finally it converted to the product. So we can see here the product is obtained which having a lower energy. Okay, याची energy कशी राहते? कमी राहते. You can see here this energy of the reactant is here at this level, and this is to be the energy of product. Okay, so there is the energy is decreases. So this is called as to be the free energy, that is the G value. Okay, always we have to be keep in your mind del G is always to be less. This minus sign, free energy gives free energy is a negative. That means their product become to be the more stable. Okay, more stable, and free energy of this molecule increases. Why? Because their activation is occurred due to absorption of light. So energy is increases. Okay, and maybe decreases. It not confirmly increases also always, but sometimes it decreases, and sometimes it may be increases. Okay, increases. Okay, so this happen, but in case of thermal or dark reaction, this free energy always to be decreases. Okay, आणि इथे काय होतं, ही increase होऊ शकते किंवा decrease होऊ शकते. Let we consider here. There is a reactant. Okay, and this reactant undergoes to be reactions, and then it produces some product is here. So this is to be the product. Okay, and the product energy is somewhat higher as compared to the reactant. So we can say here the free energy of the product is to be increased. It is to be the increased. Okay, असं म्हणू शकतो आपण. किंवा some reaction there is the energy of this product is be less than reactant. Okay, असं होऊ शकतं. दोन पद्धतीने याची एनर्जी कमी जास्त होऊ शकते, कमी होऊ शकते किंवा जास्त होऊ शकते. ओके, पण मोस्टली आपण जेव्हा थर्मल रिएक्शन बद्दल बोलतो, सो इन दैट केस फ्री एनर्जी इट इज increased. Okay, then simple in nature. Okay, this reaction is very simple, we know that. Okay, when acid is react with the base NOH, definitely it abstract the hydrogen from this molecule. Okay, definitely abstract the hydrogen of acid by NOH, and it converts to the H2O molecule, and there is formation of acetate as a counterant part. So that's why it's very simple. Okay, but what happens in case of the photochemical reaction? Okay, as we know, the chlorination of alkane is a chain mechanism. Okay, you know that chlorination. माहिती आहे का chlorination? Hello, hello, hello. अरे ऐकायला येतंय का? Anyone is here? हॅलो, ऐकायला येत आहे का रे?
येस सर येत.
अरे बोला ना रे, एखादं कोणी बोलत जा की येत आहे ऐकायला. हा, बर, हे समजत आहे का? इथपर्यंत आलं का लक्षात? ओके, हॅलो.
Yes, sir. Yes, sir.
तर ही सिंपल रिएक्शन होते. थर्मल रिएक्शन इज अ सिंपल रिएक्शन. ओके, but in case of photochemical reaction, what happens? This photochemical reaction, there is a chain mechanism. We take the example of chlorination of methane molecule. है ना, आपल्याला माहिती आहे. त्यामध्ये काय होतं, हे पहिल्यांदा इनिशिएशन होतं. त्यात क्लोरीनचं ब्रेकडाऊन होणार, दोन रॅडिकल फॉर्म होतात, and then this radical is undergoes to the reaction and from the product, but reaction does not stop until the interaction of two radicals. The reaction does not stop, it continuously going on. That's what happened. This reaction is not easy, it's not simple. Again, in which there is a different radical from this reacting chamber can interact to each other and form the different product, or simply called as a multiple product in this chamber. ओके, है ना. चेंबर मध्ये मग खूप सारे प्रोडक्ट बनू शकतात. एक तर Cl2 परत बनतो. ओके, दोन क्लोरीन रॅडिकल रिएक्ट झाले तर एक क्लोरीन आणि एक मिथिल इंटरॅक्ट झाला तर असं आपल्याला फॉर्म मिळतं. आणि जर टू मिथिल रॅडिकल जर इंटरॅक्ट झाले तर आपल्याला असा इथेन मॉलिक्यूल मिळतो. वी आर गेटिंग डिफरंट प्रोडक्ट फॉर द सेम रिएक्शन. सो दिस इज नॉट सिम्प्लिसिटी. त्याला आपण सिंपल रिएक्शन म्हणू का? हॅलो, त्याला सिंपल रिएक्शन म्हणता येईल का? I'm talking with you. It is called as simple reaction.
No, sir.
Yes, it is a complex nature. Okay. Then, thermal reaction is a fast reaction. Okay. And this is to be the slow reaction because it required more activation. And activation takes more time. That's why it is slow. Then, thermal reaction will definitely depend upon the temperature. Okay, definitely depend upon the temperature, and there is no matter of temperature. It's independent on the temperature. Okay, and their example we can consider this N2 react with twice H2, so we get the ammonia molecule. It's a very simple example for our understanding. Okay, so another some example we can consider take for this. Breakdown of PCl5. PCl5 is breakdown into PCl3 and Cl2. When reaction of H2 with I2, reaction of H2 plus I2, so we get what we get twice HI. Okay, this is to be the one of the reaction for thermal. Example is there. Then N2O5 can be break down into NO2 plus O2. Okay, and here photochemical reaction, there is a photosynthesis. Photosynthesis, very good example for that. Then visualization process by our eyes. Okay, by using the visible light and retinal interaction, cis and trans configuration is changed there. है ना, ते पाहिलेलं ना आपण. रेटिना अल्डिहाइड बघितला की नाही? त्याच्यामध्ये सिस मधनं ट्रान्स मध्ये कन्वर्शन होत राहतं, आहे की नाही श्रुती?
Yes, sir.
सिस टू ट्रान्स कन्वर्जन होत राहतं ड्यू टू प्रेझेन्स ऑफ UV light. Okay, so this is the another example for that. Then some homolytic bond fusion you can consider for this. Okay, so these are the different reaction you can be consider, and also you can be study at various medium, various website. You will get the various example, different example about the photochemical reaction. So this is all about the type of reactions. Okay, thermal and photochemical reaction. Got this point? Okay, let me move. Now we come to the next point is log of light absorption. Okay, firstly Bauger, name of the scientist is Bauger, Bauguer, B A B sorry Bouguer. This is the name of the scientist who proposed the article on the light absorption, and he gave the law about the absorption of light by the solution or absorbing medium with the thickness. Okay, thickness. Okay, related to this. Firstly, give the relation between two: absorption intensity and the thickness of the solution. So this Bauger firstly give this law. Okay, so it gives this law as when the intensity of light it fall on the medium, absorbing medium. So what happened? This light is used in a different way. Okay, some light is absorbed from the incident light. Okay, some light will be transmitted from the medium, and some light will be reflect from the medium. Okay, so this incident intensity of light is used by the medium in three different ways. Okay, also there is scattering. Okay, so in different way that light can be utilized by the medium. Okay, so what happened is here, there is the intensity of incident light is equal to summation of absorption light, transmitted light, and intensity of reflected light. Okay, but what happened? There's the reflection. If you use the air of saint cuvette or cell, sample holding cell, so there is the reflection is negligible. है ना, म्हणजे आता आपण फोटो स्पेक्ट्रोफोटोमीटर तुम्ही वापरलाय, you already use the colorimeter. Okay, and in that instrument you keep this cuvette and inside the instrument. Okay, so there is no problem of contact with the air by the cell. Okay, so that's why there is no reflection is very very negligible. Okay, so due to that skip this term, है ना, याला आपण skip करणार. So intensity of absorbing light, this absorbing light is used by the media only two way. So this is to be the instant intensity of absorbing light. Some light is absorbed and some light is transmitted. So this is the law is given by the Bauger. Okay, this law given by Bauger. But what happened? This credit of Bauger law or Bauger is enjoyed by Lambert. त्यांनी तर काम केलं, पण लॅम्बर्टनी काय केलं? Lambert extend the work of this Bauger and publishes their article with related to the intensity of light, incident light, and there is a thickness of the medium. Okay, and this law is proposed by the Lambert, so this law is known as to be the Lambert law. Okay, and that's why this Bauger is back. Okay, it goes on the back foot, and Lambert come in front. Okay, and it focus and it known for the Lambert law. Okay, लक्षात येतं मी काय सांगतोय ते. So Lambert and Beer, these are the two scientists work on the absorption of light and propose their laws about the absorption, means intensity of light by the medium and thickness of the medium and concentration of the medium one by one. And this law is basically utilized in the spectrophotometer and colorimeter. Okay, so let me see about the laws of absorption of light. And first law is the Lambert's law. So what he stated, okay, Lambert law काय म्हणतो, when a beam of monochromatic light pass through the homogeneous absorbing medium, means you consider the one cuvette, and in that cuvette you put some homogeneous solution that are able to absorb the light. Okay, so what happened? Rate of decrease of intensity of the radiation with thickness of absorbing medium is proportional to the intensity of incident radiation. So like you see here, this is the intensity of incident radiation. Okay. So what is there? काय होते म्हणते की हे जे काही इंटेन्सिटी आहे डिक्रीजिंग इंटेन्सिटी, काय म्हटलंय, डिक्रीजिंग इंटेन्सिटी with the thickness of the medium म्हणजे dx, thickness of the medium is directly proportional to I. I means the intensity of radiation. लक्षात येत आहे का? डिक्रीज म्हणजे काय होते, कमी होत आहे. ठीक आहे, डिक्रीज इन इंटेंसिटी ऑफ रेडिएशन विथ थिकनेस, इंटेंसिटी है ना, डिक्रीज इन इंटेंसिटी ऑफ रेडिएशन विथ थिकनेस is directly proportional to the intensity of incident radiation, directly proportional. Okay, so this is called as to be the Lambert law. It gives the relation in between two incident light and thickness. Second one is the thickness. Means according to the thickness, intensity of light is changed. Okay, it's varied. Okay, so it gives the equation is here. There is a decrease in intensity of light with thickness is directly proportional to the intensity. Okay, means intensity is thickness is increases. Thickness is increases. So what happens? There is the absorption is also increases. Okay. So after solving this equation, we get this final equation. There is a intensity of light. Okay, so this intensity of light is decreases exponentially with arithmetically increasing the thickness. म्हणजे हे थिकनेस जेवढी जेवढी जास्त वाढत जाईल, जेवढी जेवढी अरिथमॅटिकली वाढत जाणार, तेवढी तेवढी काय होत जाईल, एक्सपोनेन्शियली ही जी इंटेन्सिटी आहे ती काय होत जाते, डिक्रीज होत जाते. ओके, ठीक है. So let me see here. There is a decrease in intensity with the thickness by the absorption of homogeneous solution is directly proportional to the intensity. Okay, intensity of the light. So now here minus di upon dx is equal to k. K is the proportionality constant, is the absorption coefficient. K is the absorption coefficient, is a constant value. Okay, so this can be written like this. Okay, then you transfer this negative charge from this side to this side, so it can be written here di upon I is equal to minus k into dx, minus k into dx. हे इक्वेशन ला आपण असं लिहू शकतो की di आहे, di अपॉन हा I इकडे जाणार, di अपॉन I. ओके, अँड इक्वल टू, आता बघा इथे मायनस साइन आहे, तर इकडे गेल्यानंतर ते इकडे ट्रान्सफर होणार है ना, मायनस के इंटू काय राहील डीएक्स है ना, म्हणजे इकडला तो मायनस डीएक्स होता तो इकडे आला है ना, आ इकडे ट्रान्सफर. इट इज द मॅथमॅटिकल कन्वर्जन ओनली. Next, this change in intensity is very small, so integrate it. है ना, small change आहे त्यामुळे आपण त्याला थोडंसं मोठं झूम करून पाहूया. So that's why we integrate this. Okay, so after this integration, we get this equation. After integrating, we get this equation. Integrate with the limit. Is I is equal to I0, x is equal to 0, and I is equal to I and x is equal to x. These two conditions, these two limitation. Okay, so I log of I upon I0 is equal to minus k into x. आता इंटिग्रेशन ऑफ dx आहे तर त्याला फक्त x होईल आणि इकडे इंटिग्रेशन ऑफ I 0 आहे तर I, ठीक आहे. मग हे इक्वेशन भेटणार. देन अगेन सॉल्व इट. सो I इज इक्वल टू, तर हे जे लॉग आहे, लॉगला इथनं काढून घ्यायचं आपल्याला, तर इकडे हा ट्रान्सफर होईल एक्सपोनेन्शियल. सो I अपॉन I 0 इज इक्वल टू e टू द पॉवर मायनस kx. ओके, आणि मग याला आपण फायनली हे असं लिहू शकतो, I इज इक्वल टू ओके I 0 into e to the power minus k is the absorption coefficient and x is the thickness. So this is the final equation here. So we can see here, we can be stated again this law. This is the intensity of beam of monochromatic radiation decreases because there is a negative sign, decreases exponentially with increasing arithmetically the thickness of the absorbing medium. Okay, so in this way we can be stated to this law. ओके, तर इथे आपण थांबूया, आणि कारण आपला टाइम जो आहे लेक्चरचा तो एंड होतोय, आणि नेक्स्ट लेक्चर वी आर गोइंग टू बी डिस्कस अबाउट द नेक्स्ट पार्ट. बट इफ यू हैव एनी क्वेश्चन यू कैन आस्क. ओके, just any question, any query? Hello, 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 hello.
Yes, sir.
अरे बाळा, समजलं का?